Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next problem. Problem having been chosen from the book Classical Mechanics by Fowles and Cassidy. Let us see its full name. Analytical Mechanics by Grant R. Fowles and George L. Cassidy. Okay. Analytical Mechanics by Grant R. Fowles and co-author is George L. Cassidy. Okay. As usual, we first come to its statement. Okay. By finding the curl, determine which of the following forces are conservative. A, B, C. A, F equal to I x plus J y plus kz. B, F equal to Iy minus Jx plus kz square. C, F equal to Iy plus Jx plus kz square. Okay, solution. Dear students, before solving this problem in a formal manner, we have to go through a few snapshots, okay, which will develop a foundation regarding the solution of this problem. And in these snapshots, complete another problem is solved. Okay, so let us go forward and see what we are doing. Okay, conservative field. Show that the vector field F equal to this I plus J plus K so on is a conservative field. We find curl F, that is del cross F, that is curl F is equal to ijk curly over curly x curly over curly y curly over curly z, and then components along x axis, y axis, z axis. Okay, ijk coordinates along with ijk. Okay, this becomes 0. We have shown that curl F is equal to 0, and so the field is conservative. Okay, next line is not relevant at time. Okay, so dear students, if curl becomes equal to 0, then force is conservative, otherwise it is not conservative. Okay, next we once again read something about conservative field or conservative force. Okay, in summary, actually this portion has been taken from Wikipedia, and it will explain the fact that curl must be 0 in order to prove a field or force conservative. Okay, so here Wikipedia says, in summary, the curl of a conservative force field, the curl of a conservative force field is 0 everywhere, because a field being conservative is equivalent to having 0 curl, which can be derived in any basic text on vector analysis. Additionally, a conservative force field can be written as the gradient of a scalar field. This was something about conservative field. Next snapshot, which is also once again being used just as a supplement. Okay, curl. The curl of a vector field F so and so is the vector field this. Okay, we do not explain this because we have already studied the topic curl. Okay, this is just as a recapitulation. Okay, we have recapitulated our previous understanding. Okay, then once again find the curl of the vector field A equal to this. Okay, the curl of A is given by this. Okay, We do not go into detail of these two snapshots. These are just as a reference. Okay. What nutshell of these two snapshots? Rather three snapshots. Rather four explanations. Is that in order that a force or field may be conservative, its kernel must be equal to 0. If kernel does not become equal to 0, then it is not conservative. Okay. So now we come towards part A. Kernel f del cross f is equal to ijk curly over curly x curly over curly y curly over curly z. The force given was ix plus jy plus kz. Okay, we once again go. Yes, ix plus jy plus kz. Simplest form. Okay. Now, dear students, we expand this determinant. Okay. First, we are expanding it from first row. Okay, dear students, it can usually determinant can also be extended from first column. Okay, but anyhow, for the time being, we are not studying matrices and determinants. Okay, so with we have written -1 raised to the power 2. With j plus j, we have written -1 raised to the power 3. With k, we have written -1 raised to the power 4. Okay. Actually, dear students, usually we do not write this and we directly write I minus j plus k. Okay, I first column and first row are assumed to be omitted, and we multiply these minus these. Okay, minus j second column and first row is treated as having been omitted, and then we multiply this minus this. Okay, similarly plus k third column and first row are treated to be omitted, and we multiply this minus this. Okay, but actually minus with j is due to the reason that odd power of -1 is always minus. Okay, here with I is occurring in the first row and first column, so 1 plus 1 equal to 2, while j is occurring in second column and first row, so 2 plus 1 equal to 3, and odd power of -1 is always minus, while k is in the third column and first row, so 3 plus 1 equal to 4, and even power of -1 is always plus 1. Okay, so dear students, when we expand this determinant, it becomes equal to 0. This implies that force or field is conservative. Okay, now we come towards part B. Okay, del cross f curl f equal to ijk curly over curly x curly over curly y curly over curly z y minus x z square. Okay, that is actually second force given was iy minus jx plus kz square. Okay, we can move backward to but there is no need. Okay, with this we have I, with this we have j, and with this we have k. Okay, iy minus jx plus kz square. Okay, so here in the same manner as we did in previous part A, minus I minus 1 square into 0, because dear students, this will be terminated. Partial derivative of z with respect to y is always 0, with respect to x is also 0. Only with respect to z it can be 2z, but here it is not being with z. Okay, so this is 0, and partial derivative of x with respect to z is always 0, with respect to y is also 0, only with respect to x will be -1. Okay, so similar is the case with other, and hence dear students, 0 into 0 into minus 1 minus 1. Okay, when we will expand this plus k minus 1 raised to the power 4, first row and third column will be treated as omitted. This partial differentiation of x with respect to x will be minus 1 minus partial derivative of y with respect to y will be plus 1. Okay, so minus 1 minus 1 minus 1 minus 1, it will become minus 2 because it does not become equal to 0, not equal to 0. So this implies that this force is not conservative, this field is not conservative. Okay, now similarly see del cross f, kernel of f, kernel f ijk curly over curly x curly over curly y curly over curly z y x z. It means given force will be iy plus jx plus kz cube. Okay, iy plus jx plus kz cube. Okay, now here when we expand it from first row, when we will take I, first column and first row will be treated as omitted, and partial derivative of z with respect to y is always 0, with respect to x is also 0, only with respect to z it will be 2z, but here this is not the case, so it will be 0 minus partial derivative of x with respect to z is 0, with respect to y is again 0, only with partial derivative of x with respect to x will be 1, but this is not the here case, so 0 plus j, second column and first row will be treated as omitted. Partial derivative of z cube with respect to x is always 0, with respect to y is also 0, only with respect to z it will be 3z square, but this is not the here case. Okay, similarly this minus partial derivative of y with respect to z is 0, with respect to x is also 0, only partial derivative of y with respect to y will be 1, but this is not the case here. Okay, plus k, third column treated as omitted, first row treated as omitted, partial over partial x x. Okay, quite okay, it is 1. Partial derivative of x with respect to x becomes 1. Similarly, partial derivative of y with respect to y becomes 1. But here formula is that this product, this minus this, so 1 minus 1 0. Okay, our previous have been proved already 0, and this basically does not become 0, but 1 minus 1 at later stage, at subsequent stage it becomes 0, and hence curl f finally becomes equal to 0, and hence it means that conservative. Okay, this is the end of our problem, this is the end of our video. Till next video, Allah Hafiz.